Now, so what we did, we identified the data. We saw that what is its sensitivity, what is its compliance requirement, and now we apply controls depending upon the sensitivity or the importance to that organization, right? What controls we apply, we will see. Okay, it might be encryption, it might be tools are there are many tools, right? You might have to physically protect something, you might have to logically protect something, you might have to administratively protect something, and that's as per your risk assessment which you did in domain one, right? But here the importance is, are you able to identify what is important to you, and then are you able to classify that information, what is important to you? And once you've classified that information, then your data asset uh, identification and classification processes over. Okay. Now, once you've done that, right? Once you've done that, you have to protect that data. Now, so if you have, say, a data which is confidential in nature, then you will lay down a policy. You will say, okay, let's encrypt this with AES, okay, 256, right? Emails should be, we will use secure email only for transmitting data. There'll be no printouts, okay, no prints, okay. So see, this is the administrative control, okay. This will be a technical control. This will be a technical control, okay. You will say that the main server room where the email server is there, okay, there will be no access, okay. So you will have a physical control also, right? So if you see, all controls can have, you can implement to achieve the desired level of security, which is being, regulated by the classification you have given and the policy which you made in domain one, that is security and risk management. Okay. Now this is where the correlation comes in, right? Okay. So now, once you have identified the data, and now you will also have to identify the systems which are using this data, right? And those systems will be classified at the same level. Right? If certain systems handle PHI, those physical systems or logical systems will also be given that same importance. Okay, but you have to see whether the data resides inside those systems at rest or not. You might just be using that data, okay, it will be only for use, but the storage is happening in your storage area network or cloud network, and use is happening on the CPU, okay, while the data is moving from cloud to storage to your device. So you have to identify the cycle and understand the system, what kind of control at what kind of level. So controls at the use will be different, controls at storage will be different, controls in the cloud would be different, but all driven by your classification and your identification process which you did earlier. Okay. Now, once you have data, you have to maintain the data. You have certain asset handling requirements, okay? Because assets have a bond time, they're used, and then they are discarded. So they have a life cycle of their own. And that's why you have to have a asset handling requirements. And first part of any asset handling is, data maintenance. Okay. Now, suppose you collected PII, it came in your system, and it was in your storage area network. Your storage network suffered some kind of a malfunction, and your entire data got, corrupted. Or you had certain proprietary data which was stored in some cloud, storage, and this cloud storage by mistake got deleted. Okay, so that means you have to maintain data over its life cycle. And how you do that? You have controls, okay, you have backup policies, you have to back up, you might have policies for maintaining how the data is going to stay where. So maintenance only doesn't mean protecting the data. Maintenance also means how it affects the confidentiality, integrity, and availability. That means data should be protected, data should remain intact, should not have any unauthorized changes, and availability. Now imagine where your cloud storage is deleted. What will it affect? It will affect the availability of your data. So a good organization will have a good data management policy depending upon the systems which it has in its place. Okay. Now, first thing that we know is data should be prevented against losses. Okay. Now the first way in which you can prevent data loss is by implementing something called data loss prevention systems. So what are data loss prevention systems? So once you have data in your organization, it's always marked. Okay, it has some kind of a data labeling. You need to have a label. So it might have some visible labeling, it might be confidential visible, or it might have a metadata. What is the metadata? Data about data. And in this metadata, you can have certain tags which can be recognized by your DLP systems. And if there are any unauthorized exfiltrations, if there are any unauthorized exfiltrations, you will be able to detect it. Why? Because it will detect this tag. Okay. Data loss prevention systems are of two types. One is host based and one is network based. Okay. Host based systems will detect data loss by unauthorized processes by looking for these tags in the host itself. Host means either a server or a laptop or a desktop, whatever you're using. The moment it goes out on the network, this is the interface where it will check that are you authorized? Is this process authorized to throw the data out? Okay, and that such systems are called host-based. Whereas network-based DLP systems, if you have your switch and you have your entire network, right? The network DLP will probably sit in between. I've not seen network DLP, but this is what it will do. It will read the headers of any data which is moving out. So it will read the headers. If the header has a tag, DLP system will read this tag and stop the exfiltration of this data by a unauthorized process. Okay. Clear? Network-based DLP and host-based DLP systems. That means if DLP systems have to work, your data assets have to be marked. Marked either physically or logically. Now, physical marking is visible. Logical marking is not visible. It has got a metadata tag. Metadata tags are nothing but certain kind of labels, data about data. If you open any photograph on your mobile phone and read about the data, you will see location, you will see the time at which this photograph was taken. That is the data about the actual data, which is the picture. And that such data is called metadata. And that's why data marking is very, very important. Now, data marking, logical data marking is fine, but at times you might have to do physical data marking. Means, say you have backup systems, backup tapes, backup hard drive, backup SSDs, and you have to store this data because it's got some important compliance data which needs to be stored for 15 years. But this data, asset, some HDD drives have lived their life. Okay, they've lived their life. What do? You mark them. Say if the data is got PHI, you mark them as confidential, and stored it in your data repository. Either you have a physical repository of your own, or you have a third-party repository or a hired repository where you store this data. Okay, so that's why marking is very, very important. Okay, if you don't mark data, you will not come to know whether data exists or doesn't exist. Also, at times you might have to downgrade the importance of data, downgrade the importance or sensitivity of data, right? Means you filed for patent and you had some, you had some product which has now lived its life. Now, no point protecting that data for a long time, right? You can downgrade that data as public, and many times we have seen, organizations, come out with what happened in the past because that data is not relevant anymore. So it's very important to downgrade data. Also, otherwise, you will have a hell lot of sensitive data accumulating at your end. And as an information professional, you'll have to keep evaluating it that, what data needs downgradation, what data is not required anymore. Let's expunge that data from our organization because it is not required anymore. Okay, clear? Okay. Now, once you want to protect data, right? If you want to protect data, you have to, if it is sensitive data needs to be handled in a proper manner. It needs to be handled properly. Okay. Even when you are collecting it, even when you are processing it, or when you are storing it, and even when you are discarding it. That means if you're collecting some PII data from me, you're going to collect it, then you're going to process it, then you're going to store it, and then finally, when you don't require it, you're going to destroy it, right? So this is the data life cycle. And that's why it's important that as InfoSec professionals, you are very, very clear what kind of data is that you are going to collect. Now, suppose you're supposed to only collect my name. Then why are you collecting my mobile number? Or why are you collecting my address? That is called data collection limitation. What is it called? Data collection limitation. As InfoSec professionals, you should always guide people that only collect the data which is required. Don't collect data which you don't require. Say, you are a bank and you are only supposed to you are supposed to verify the KYC that this is the person. When the verification is done, that is enough. Don't store his KYC data on your end. But banks at times take KYC physically from you and store at their end. That means they're taking that additional responsibility of saving that KYC information, because if that gets leaked out from their custody, they are responsible, right? That's why don't collect data which you don't require. That is first principle of data, since handling sensitive data. Don't collect what you don't require. Only collect what you require. Okay. The second concept is of data location. Where are you storing the data? Okay, you've collected it. Now you're storing it on a normal endpoint on the user's device. That would be a very, very long, wrong thing. So you should know where you are going to store the data, how are you going to protect it, and where are you going to have its backup, okay, if required. If you need to have its availability assured, then you need to know what is the location of the data. Where does it reside? Because if you have marked sensitive data and you don't know where it resides in your organization, then it would be a difficult thing for you to protect that data. Okay. Then whenever you are storing sensitive data, it's important that you encrypt it. Because if you don't encrypt it, then it is very sure that you are going to lose that data. Okay. So you should encrypt it properly. You should take backups. Okay. And you should ensure that the media in which it is being stored, that media is also protected properly against some climatic issues or some kind of failures do happen on HDD drives and SSD drives. So you need to protect even the media on which you are holding that information. And finally, when all this has happened, you are supposed to destroy. Once you don't require the data anymore, you're supposed to destroy that data. Now, destruction of data in itself is got a huge document of destruction as per as NIST is concerned. It's called Guides for Media Sanitization, right? But destruction is very something which is important. Once you don't require the data, you're supposed to get rid of that data. Okay. Now, what happens once you use in the digital world? Once you look at data destructions, you look at a hard disk. Okay, whether it's an SSD drive or an HDD drive, anything, you have data over it, and now you don't require. What do? You delete it. Now, does deleting actually delete the data? It doesn't. Okay, it only deletes it tells the program that don't look at this data anymore. Okay, the entire space is available to you for overwriting. That means the data still exists. This is called data remnants. Now, digital data has a habit of remnants. it stays even after you delete it or you scrub it. Why? Because most of the time data used to be written on magnetic tape drives. Now, magnetic tape drives have a habit, even after they are rewritten, the old data is still visible. You can retrieve the old data. And that's why, if you remember 20 years back, if your hard disk used to crash, you used to go to the local shop and say, Bhaiya, please, get this, data back from my crashed hard drive. And they could retrieve it by using certain special softwares. Why? Those softwares could read the data which was there on the magnetic drives. Okay, data remnants is an issue. Now, if you want to destroy the data and you are just writing it over, you are not losing the data. So that's why you need to have controls which can, which can actually remove data from these devices. Now, this is as far as hard drive is concerned. HDD drives were magnetic drives, but SDD drives are actually flip-flop drives. And they cannot be overwritten. They cannot be overwritten. You cannot overwrite and assume that the data has been removed. The only way SSDs can be cleaned, SSD, sorry, not SDD, SSDs. The SSDs can be cleaned is by either encrypt it and then lose the key. Such kind of erasure is called cryptographic erasure. So whenever you're trying to lose data from SSDs, you have to actually, do encryption and then lose the data. You cannot clear or erase data from solid state devices. Okay, you should understand that. Most of the solid state devices come with a erase button. It's got an erase button, which actually kick off a erasure cryptographic control by which it is encrypted. Okay, most of the SSDs. Okay, so this you should remember because SSDs cannot be degaussed or just cleared or written over. SSDs will retain the data. Now, there are ways in which you can destroy data. Now, first form is called erasing data. Erasing is you have the hard disk. Okay, you just perform a delete operation. Now, delete operation never erases the data. Data is there. It just removes the marker where the data removed. It is actually deleting this reference. CPU, refers the hard disk by certain markers. You just release the markers. Data exists. So erasing is not a good way of destructing data. Okay. Then the second thing is clearing. What is clearing? Clearing is, you take a bit stream 00000 and write it on the entire disk. Okay. This is just a simple form of more advanced form, or it is an advanced form of overwriting. You can have a random pattern of bit. You can write random patterns of data and write it over once. That's called clearing. Okay, overwriting. Then third way is purging. Now, purging is actually more intense form of clearing. That means it overwrites data multiple times. It first pass, second pass, third pass, fourth pass, and every time the bit stream is different. It is more hard form of clearing. If you remember 10, 15 years back, we used to have something called purging softwares where you give a bit stream and say purge my hard disk, and it would write 1,000 times, 2,000 times. What happens is purging generally, it degrades the magnetic drives, because those days used to be magnetic drives, and purging used to be done if you want to reuse the media again. Now, purging is still not used in US for top secret documents because US government feels that top secret, even after purging, you can retrieve the data. Okay. And final way, the way in which you can actually get rid of data is by degaussing. What is degaussing? Degaussing is putting your hard disk drive inside a very strong magnetic field. basically degaussing. If you are a science student, you go back to Gauss theorems and all. Basically, uh, hard disk drive is nothing but magnetic lines of force. You put it in a very strong magnetic field and you corrupt the entire magnetic field inside your hard disk drives. Now, degaussers only work on magnetic drives. That means tape drives and HDDs. It will not work on USB solid state devices. It will not work on SSDs. Okay. The only way you can get rid of data remnants from SSDs is by putting it in an incinerator and melting it. Okay. That is the only final way of, destroying data. Okay. Now, this is as far as data erasure was concerned. Finally, if you have to destroy, there are many organizations which do not reuse their media. They just finally destroy it, and they don't even sell it to any scrapyard. They actually shred it into physical shredders and get rid of the hard drive itself. Okay, clear? Any doubts? And finally, is something called cryptographic erasure, which I told you already. I will just explain to you once again. Cryptographic erasure is a good strategy to erase data from solid state devices and in cloud. Okay. Now, how you store data in cloud is you got buckets. Buckets are nothing but storage space allocated to you. Now, once you've written data over here, if you do not erase it, that means because this is a shared cloud is a shared resource, tomorrow this hard disk space or the disk space might get allotted to someone and they might be able to retrieve data from there. Okay. So good way of getting remnants of this data out from the cloud is using something called cryptographic erasure. What is cryptographic erasure? You encrypt using some kind of encryption protocol, say AES 256, and you take the key and you shred this key. You lose this key so that this key is not recoverable anymore. Once you've shred this key, now this data is in an encrypted form and you cannot retrieve it back. Okay, that is called cryptographic erasure. And the same methodology can be used on solid state devices. You encrypt the solid state devices with the AES 256, lose the key, and this data is encrypted. Nobody can retrieve it. Such form of data erasure is called cryptographic erasure. And such methods are used on cloud and on solid state devices. Okay. Clear? Any doubts?
No.
Okay, great.
Colonel, as you mentioned, the bucket.
Yeah.
Bucket, for example, suppose I am the user, I am the entity user of that particular bucket. So that bucket will be given to me only for my usage. So none of the other user can come into that bucket and can store their data on that particular bucket.
Yeah, but the day you don't need that bucket, you are going to release that space, right? In cloud, you've used cloud, right, Ismail?
Right.
So on AWS, say you are using okay, you are using a AWS S3 bucket, right?
Right, S3 bucket, right.
Now this S3 bucket is actually nothing but some kind of a space on some solid state device, right?
Right.
So you have
it's basically a folder. For example, how in your desktop, similar to our
folder in your desktop in the cloud, but ultimately it is some location on some physical device, right?
Right.
Even your folder on your desktop is nothing but a location on your hard drive, right?
Right.
Okay, so similarly on cloud, this S3 is nothing but a folder on a solid state device which you have rented for the duration of your use.
Right.
So now you have not encrypted this data. You have some data and it is not encrypted, right? It is being here. It's here, right?
Okay.
Now I'm not using AWS. Okay, AWS now has a default encryption on S3. I'm not using AWS as example, and that's why CISSP and ISC2 are vendor agnostic. We don't take vendor into consideration. We're taking concepts into consideration. So I'm just taking an example of AWS to make you understand, because most of us has worked on AWS, right?
Right.
So you have taken this bucket, you've put some data here, and then now you don't need that bucket anymore. So you release that bucket. Why? Because otherwise it's billing you, right?
Right, of course.
It's billing you. So you now don't need it, you release it. Now, the moment you release this, you don't have any control over this space. That
Okay.
means relation which was there between you and this folder
AWS.
does not exist.
Right.
Okay.
Okay.
Now I come in and I take a bucket.
Okay.
AWS allocates the same memory space from the SDD as an S3 bucket to me.
Got it.
You have
Okay.
not erased it. This is not visible to me, but it gives me a possibility that I can retrieve that data. I mean, maybe as a user, I may not be, but look at AWS, who is managing this data center. There
Mm-hmm.
is a possibility that an internal threat might access this SSD and take out this data. Look at this another way around. AWS is discarding these SSD drives tomorrow, and your data is written here. Nobody has used this space, and your data is written here. And
Right.
AWS goes, it's not AWS, any third party software cloud provider. They go and sell it to a scrapyard. And somebody like me goes and buys hard disk from scrapyard to retrieve data and see how can I expose organizations,
Okay.
and then blackmail you. Just a small example, right?
Yeah.
But there is a risk, right?
Yeah.
There is a
Exactly.
risk. Do you agree?
Yeah.
So I
Agree.
encrypt, I encrypt and lose the key. Even if I retrieve it, this data is encrypted. I'm not interested because I know I cannot decrypt AES 256.
Right.
And that's why if you see at AWS, AWS now supports default AES 256 data at rest using cloud service provider key, CSP key. If you have forgotten, AWS on default takes a key and encrypts your data.
Okay.
Got it?
Got it. Got it. Thanks.
Okay, so cryptographic erasure, good strategy for cloud. Those who are cloud security professionals, they generally are aware of this.
Thank you for watching. Don't forget to subscribe our channel.